Hi, this is Mr. West, and you are watching a walkthrough video for inequalities on a number line 3. This is from Math-Salamanders.com. Make sure to check out Math-Salamanders.com in the link in the description below. They have amazing math resources, so let's check this out. For this worksheet, we are going to have to draw graphs for all of these inequalities on the right. So just a quick summary. I'm going to try to speed this up a little bit. Number one, inequalities. They are expressed like this. The whole idea, like the second grade concept, is the inequality wants to eat the bigger number. So there's a bigger number facing the mouth of the inequality, and it doesn't matter which side it's on as long as it's opening up to it, and then the smaller number is on the outside. So as we're graphing these, we have two different types. One is a less than or equal to or greater than or equal to sign. Notice how these are like a combination of both these symbols. That means it can be either or. For example, this is true, but also, let me slide this down. So 2 is less than 5, but it's not equal to 5, but it's less than 5, so that works. But also, this is true. So if we had 1 is less than or equal to 1, it's not less than, but it is equal to it. So that's what the less than or equal to or the greater than or equal to sign mean, and we're going to represent that with a solid dot. Now, for the less than sign, 2 is less than 5. However, if we were to make it 1 is less than 1, that would not be true. So this is not true. Therefore, 1 would not be a solution, and we would represent that with an empty circle, okay? All right, now 2 more things we need to talk about. One is where to graph the line, okay? So to the right, we're going to call that greater. If we have something to the right that is greater than, notice how all these variables are being eaten by the alligator, okay? They're greater than some number. So some number over here is smaller than these variables, which are big and big. And it doesn't matter which way it's eating the variable, to the right or to the left. As long as the variable is getting eaten, that means the solutions are greater, okay? So I think that's important. I'm going to talk about that later. The solutions are greater than whatever number was listed here. And over here, the converse is also true. So less than, some number on the inside is bigger, and it's being eaten by all these signs. So notice all these signs are facing the bigger number on the inside. That means the solutions are smaller. And we're talking about smaller, we're talking about to the left. So left are the smaller values, right are the bigger values or the bigger solutions, okay? So how do we translate that into graphing up here? Well, anytime it gives us a number, so right here we have x is greater than -4. Based on what I said before, we should be able to read that just fine. So we're going to go ahead and find -4 to start. That is right here, okay? Now, I'm not going to do anything yet, so I need to decide, is it a full circle or is it an empty circle? And I know it's an empty circle because -4 is not a solution. If I were to put in -4 here, -4 is not greater than -4. That's not true. So we need an empty circle because -4 would not be included in the solution set. Now, some people like to graph above the line. I personally like to graph right on the line. It's up to you. I'm going to go ahead and graph above the line this first time and then maybe change it up. So -4, I'm going to put a circle right on there at -4. Now I need to decide, is it going to the right or is it going to the left? That's the important second step because the inequality represents a number of solutions, not just one like an equal sign does. Notice how it's eating the variable. That means the solutions are bigger than, and that was our empty circle, -4. So if they're bigger than -4, bigger means going to the right. So we need to graph this to the right and not to the left. So I'm going to take I'm actually going to make this maybe a little bit bigger. And I'm going to graph this to the right. I like to do it with a nice thick one like that. And then let's make this a little thicker, just like that. That's pretty good. So this represents all the values that are bigger than -4. And I could test it. So for example, if I were to test the point 5, okay, is 5 part of the solution? Well, is 5 bigger than -4? See how I replaced the x with that 5? Well, that's true. Therefore, 5 is part of the solution, and any number to the right is part of the solution. Conversely, I could test a number that's to the left of this critical point, -4. Is -10 bigger than -4? And the answer is no. -10 is not, and none of these numbers to the left are going to be solutions. Therefore, we need to shade our line to the right. Okay, so that's how we do these basic ones. We'll do one more just so we get the hang of it. So if I'm looking at x is less than or equal to -2, or sorry, +2, I'm going to first start, is it open dot or closed dot? It's a closed dot. Okay. Next, am I graphing to the left or to the right? Well, since the solutions are less than 2, that means smaller than, I'm talking about all the numbers to the left of 2. So I can go ahead and I can just, let me make this thicker again. I can go ahead and just shade in all these values over here. I like to go to inner line and make sure to put an arrow, and that tells you that there's an infinite number of solutions that make this true. You can always find numbers that are smaller than 2. And that's what our solution is going to look like. You can see 1 is above the line, 1's on the line. I'll leave it up to you and your math teacher to decide which one is correct. But I personally like right on the line because, yeah, it's just preference. Okay, now let's move on to some other ones because these ones are a little bit different. Notice how there's 2 values this time, okay? And I think all of them are like this. Yep. So there's 2 values this time for number 3. Notice how we have a 1 and a -7, okay? So we're going to start by finding those numbers, 1 and -7. Not doing anything yet. I need to decide, is it open or closed dot? Okay, and it is an open dot for both of those inequalities. So I'm going to go ahead and find one. I'm going to put in open dot. I'm going to do it above the line this time. Okay, so above the line, we got an open circle. And now we need to decide, okay, what do we do? An x is in between. What does that mean? Well, consider both separately. If we have x is greater than -7, what would you do? And then if we have x is less than 1, what would you do? Okay, and there should be some overlap there. So x is greater than -7. That means all the solutions that are bigger than -7, that means to the right. So I'm going to start at -7, and I'm going to graph to the right. And notice how before, remember, I want to keep this line straight. Well, make it a straight line first. And notice how I go right through my point. This should represent like, hey, this is a problem. Why am I going through this point right there? That can't be like kosher, right? That's not a good thing. So let's go ahead and check out a different way to do this, okay? Because it can't go all the way through. But first, let's consider this other inequality. X is less than 1. That means all the solutions that are smaller than 1 to the left. So I'm going to go ahead and do the same thing, and I'm going to go right below it. Oops, having some trouble here. I'm going to go right like this. Okay, and to the left. Okay, and you can see where we have some overlap. This overlap is the solution area. So really what we need to do is we need to erase all this stuff, okay, because that is not going to be part of the solution. Neither is this going to be part of the solution. And it can't be on the inside because 1 is not a solution. So we're just going to get rid of all the stuff to the right and to the left, and the overlap is where the solution is going to be. Now I have it kind of all funky on the inside here, so I'm going to go ahead and erase it. Okay, and I have some little scraps on the outside. It's not a big deal, but I like to keep it clean. Okay, so really what happens here is x is all the values in between. The solution area is in between these 2 points. And notice how x is in between these 2 values. So what ends up happening is it's like this barbell. Okay, it's like these 2 circles with this bar of solutions in between, and that's how it looks. And that's how it's going to look for all of these, okay? So for number, I'm going to look for if there's any, number 8. So number 8, this will be our last one. I'm going to find 9 on the number line, okay? And notice how it's a less than, so I'm just going to make an open circle. And then, that's kind of a bad open circle. Let me make it a little bit bigger. All right. So 9 is an open circle, and then I'm going to go to 2, and this one's going to be a closed circle, okay, because 2 can be included. And x is the values that are bigger than 2, but less than 9, okay? Bigger than or equal to 2, but less than 9. So I need to stay in this solution area. Just like x is in between those in the inequality, it needs to be in between these values on our graph. And we're done. That's all there is to it. So I hope you enjoyed this video. Make sure to check out more videos like this on my math YouTube channel. And I look forward to seeing you next time right here on West Explains Best.